Hi guys, Sagar here. Today we have the 7th question of exercise 12.2. So it says 2 feet of equal heights are standing on opposite to each other on either side of the road. So let's draw two lines representing two poles. So let this be the first one and let this be the second one. And it says the road is 120 feet wide. So this horizontal line is 120 feet wide. Next he says from a point between them on the road, so let this be some point on the road, the angle of elevations to top of the poles are 60 and 30 degrees respectively. So let this be one angle of elevation and this be other angle of elevation, and it says one is 60 degrees and other is 30 degrees. Next, we need to find the height of the poles and distance of the point from the pole. So we need to find this length of pole, that is, let this be x, then this is also x, and we need to find the length of this y and length of this, that is z, some points s, x, y, z, and let these points be A, capital B, capital C, capital D, and let this point in between be E. Now we have two triangles and we need to find the length of x, y, z, and if we can observe down here, the length of adding y and length of adding z will get 120, because they said the road is 120 feet wide and the distance of point E to foot of pole A is y and distance from point E to second pole is z, so y plus z equal to 120. Next, in triangle ABE, the first triangle, we can see that we are using opposite side and adjacent side. So let's use tan here. So tan E is equal to opposite side, that is AB, by adjacent side, that is BE. Tan E is equal to 60 degrees. So tan 60 is equal to AB is x and BE is y. Next, tan 60 equal to root 3 is equal to x by y. So if I bring y to the left hand side, I would get x equal to root 3 y. And let's name the equation. Let this be first equation and this be second equation. Next we have in triangle CED, we are using same adjacent side and opposite side, so let's use tan here. But now tan E is equal to CD by ED. So tan E is equal to 30 degrees in triangle CED. So we have tan 30 is equal to CD is x by ED is z. Now tan 30 equal to 1 by root 3. 1 by root 3 is equal to x by z, and if I bring z to left hand side, I would get x equal to z by root 3. Let this be the third equation. So we can see x is equal to z by root 3 and x is equal to root 3 y. So if I compare the both equations, so comparing equations 2 and 3, I would get root 3y is equal to z by root 3. Now if I bring this root 3 to left hand side, I would get z is equal to 3y. So if I let this be equation 4. Now I substitute substitute 4 in equation 1. So what is equation 1? Y plus z is equal to 120, but z equal to 3y. So y plus 3 is equal to 120. Now y plus 3y is equal to 4y, 4y equal to 120. Now if I bring this 4 to right hand side, I would get y equal to 120 by 4, and 4 3s are 120, sorry 30s are 120, so we got y equal to 30 feet. But we know that y plus z is equal to 120, therefore z is equal to 120 minus y, and y is equal to 30, so 120 minus 30, therefore z we get it as 90 feet. And lastly, we need to find the length of the pole, that is x. So we can use either of the equations, that is equation 2 or equation 3. So let's use equation 2, x is equal to root 3 into y. So let's use substitute y in equation 2, that is x is equal to root 3 into y. But y we know it as 30 feet, so x will be 30 into root 3 feet. Now if I substitute root 3 is equal to 1.732, then I would get 30 into 1.732 is equal to 51.96 feet. That's it. So we first draw the diagram. We name we want to find with some variables, that is x, y and z, and with by simple calculations by using tans and the equation, that is y plus z equal to 120, we could figure out the length of the height of the tower, length of pole, and foot of the poles and point. So we can see x, so the length of pole we found it as 51.96 feet. The BE, so the distance between point E and foot of first pole, that is y, that we found it as 30 feet, and distance between point to second pole, that is z, we found it as 90 feet. Thank you. Hope you understood the question. Subscribe for more one. Thank you.